Hello everybody, welcome into another lesson. So today we are going to do part 2 of using matrices to solve a 3-variable system of equations. So here you have your 3-variable system of equations. You have various coefficients on your x, y, and z variables. Then to the right of the equal signs you have what all those equations are equal to. And like we did before, or as we did before, I should say, you're going to convert these into a matrix. You're just going to, since you have 3 equations, you'll have 3 rows. So you just take the coefficient on your x, your y, and your z variables for each row, and then to the right of the line of augmentation, you'll put what those equations are equal to. Unlike the previous lesson when we just worked in row echelon form, where we had to use back substitution after we solved for one variable, we had to use back substitution to find the other 2 variables, which made it a lot more likely you're going to make simple math mistakes when solving. Reduced row echelon form, like we talked about in the very last lesson when we did part 2 of the 2-variable systems of equations, enables you to directly see what your x, y, and z values are. We're going to convert this into reduced row echelon form, where the leading digit in the first row is still a 1. That's your first digit, and then both other digits are 0. So this is telling you that x equals a. In your second row, your first digit's a 0. The second digit is a 1. You have a leading 1, and then the digit after it's also 0. This tells you that y equals b. And then your third row, your first 2 digits are 0. And then your last digit is a 1. You have a leading 1. This tells you that z is equal to c. No back substitution required. And this here is the 3x3 identity matrix, which is what you should get to solve your system of equations. On the left side of the line of augmentation, you'll get this identity matrix for a 3x3 system. So from the first row with the 1, you should have 2 zeros below it. In the second row with the leading 1, you should have a 0 above and below it, and to the left and right of it. And then for your leading 1, the third row, you should have 2 zeros to the left and above that 1. So we're going to get into some examples here of how exactly this is going to work. I have about 6 problems. That's all I have, 6 problems, and then we'll be done with the lesson for the day. So let's see here. We have 2x plus 6y plus 3z is equal to 2. We have x plus 3y plus z equals 1. Then we have x plus 5y plus 2z is going to be equal to negative 1. Alright, so there is your system of equations. We got these 3 equations with variables x, y, and z and their various coefficients. So let's set up our augmented matrix first. So 3 equations means 3 rows. So in the first row, take the 2 that's on the x, the 6 that's on the y, the 3 that's on the z, and then to the right of that line of augmentation, put your 2 there. Alright, second row, take the 1 that's on the x, the 3 that's on the y, and then the 1 that's on the z, and then to the right of that line of augmentation, put your 1. And then your third row, take the 1 that's on the x, take the 5 that's on the y, and then take the 2 that's on the z, and then put that negative 1 to the right of the line of augmentation. Okay. If you're able to, what you should do, if you have to do so, swap out row 1 with one of the other rows. to make the leading digit in your first row a 1. It's going to make your life easier in the end. I'm going to personally suggest we swap rows 1 and 3. Let's do that real quick. It literally doesn't change the system itself. It's just we're swapping rows. So we haven't even added or subtracted anything yet. We're literally just swapping places with rows 1 and 3. So, and make this a little bigger. Alright. So now row 3 just became row 1. So you'll have 1, 5, 2, -1. Row 2 we're leaving alone. You still have 1, 3, 1, and 1. And then row 1 just became row 3. So you have 2, 6, 3, and 2. So now we're dealing with a 3 by 3 matrix, which means we need to make the first digit in both the second and third rows be 0. It's great that you have a leading 1 already in the first row. You can leave that alone for the time being. But the first digit in your second and third rows both need to become 0. So to deal with row 2, if we just take the negative of row 1 and add that to row 2, we can make that happen. And then if we take negative of row 1, if we take -2 times row 1 and add that to row 3, we can make it happen there. So the good news is with matrices, you can do more than one row at a time to streamline the process. So row 1 we're still leaving alone. 1, 5, 2, and then -1. Alright, so let's deal with negative of row 1 plus row 2. So -1 plus 1 turns into 0. Alright, -5 plus 3 is -2. And then -2 plus 1 is -1. And then -1 is +1 plus 1 is 2. So there's your new row 2. Alright, now take -2 times row 1 plus row 3. So -2 plus 2 turns into 0. Alright, -2 times 5 is -10, plus 6 is -4. -2 times 2 is -4, plus 3 is -1. Alright, -2 times -1 is +2, plus 2 is 4. So far we've started to accomplish our goals a little bit. So what you want to do now, we've got the first digits in rows 2 and 3 to be 0. The very next thing I'm going to suggest we do, just deal with row 3, make that second digit in row 3 also a 0. So we'll start there. Make that second digit in row 3 also a 0. In order to do that, I'm going to say we take -2 times row 2 and add that to row 3. So -2 times row 2 plus row 3. Let's do that real quick. So we're still going to leave rows 1 and 2 themselves alone for now. Alright, so then let's see. Row 2 is being left alone for this one at least. Alright. So let's see. -2 times 0 is 0, plus 0 is still 0. -2 times -2 is +4, minus 4 is also 0. Alright, -2 times -1 is +2, minus 1 is 1. And then we have, let's see, -2 times +2 is -4, plus that 4 is 0. Well, we got row 3 where it needs to be now. The first two digits of row 3 are a 0, and you have a leading 1. So we're done dealing with row 3. The next thing I'm going to suggest we do is go ahead here. You're actually going to want to make the third digits in rows 2 and 1 both a 0. Make those third digits in both rows 2 and 1 a 0. So let's start with row 1. If I take -2 times row 3, add that to row 1, I can make that happen. And then if I just take row 3 and add it to row 2, I can make that happen also, and for both of those rows. So let's go ahead and do that here. So let's see here. Let's see, you still would have 0 plus 1, which is 0. 0 plus 5, which is... Wait, 0 plus 1 is 1. What am I saying? 0 plus 5 is 5. Okay. -2 times 1 is -2 plus 2, which is 0. Alright, let's see. 0 plus -1 is still -1. Alright, so there's my new row 1. Now we're just literally going to add row 3 to row 2 to get rid of the -1 here. 0 plus 0 is still 0. 0 plus -2 is -2, but 1 minus 1 is 0. And then 0 plus 2 is 2. And then, of course, you have 0, 0, 1, 0. All right. We're almost done, but we have a leading 1 in row 3, but the leading digit in row 2 is a -2, where it should be a +1. So let's start by taking -1/2 of row 2. We'll just simply do that. We'll get a new row 2. So leave row 1 alone for the time being. All right, -1/2 of 0 is still 0. -1/2 of -2 is 1. -1/2 of 0 is 0. -1/2 of +2 is -1. And then we just have row 3. All right, that's great. So we've got rows 2 and 3 in reduced row echelon form. We're almost done. In fact, the leading digit in row 1's a 1. We just need to make the second digit in row 1 also 0, and then we'd have it in reduced row echelon form. So if we take -5 times row 2 and add that to row 1, we can make that digit a 0. -5 times row 2 plus row 1, we will get our final matrix here in reduced row echelon form. So -5 times 0 is 0, plus 1 is still 1. -5 times 1 is -5, plus 5 is 0. Let's see, we still have 0 plus 0, which is 0. Alright now, so -5 times -1 is +5, minus 1 is 4. And then you still have rows 2 and 3, which stayed the same. Which now we have our matrix in reduced row echelon form, which is telling you that x equals 4, y equals -1, and then z equals 0. So this time it's going to represent an ordered triple. That's the solution to where these three planes intersect. That'll happen at the ordered triple 4, -1, 0. That will be the solution to where these three planes intersect, would be at 4, -1, 0. And I got 5 more problems here. what's the next one? So I have 2x plus 6y plus 3z, this time is equal to 8. Then I have x plus 5y plus 5z equals 1. Then I have x plus 3y plus z equals 3. So there we go. There's the new system of equations right here. Let's form this into a matrix. So 3 equations means 3 rows. So take the 2 on the x, the 6 on the y, the 3 on the z, and then to the right of that augmented line, put that 8. All right, put the second row, take the 1 on the x, the 5 on the y, the 5 on the z, and then to the right of the augmented line, put that 1. And then third row, take that 1 on the x, the 3 on the y, the 1 on the z, and then to the right of the augmented line, put the 3. There is your matrix that represents this system of equations. Again, as I said in the last exercise, try to, if you can, swap rows so that the leading digit in your first row is a 1. We're going to swap rows 1 and 3 again. We'll just start there. So that's going to make life a little bit easier if we swap rows 1 and 3. So to set that up, we'll have, see, row 3 becomes row 1, so you'll have 1, 3, 1, and then 3. Row 2 is left alone for now. 1, 5, 5, 1. Then row 1 became row 3, so you'll have 2, 6, 3, and 8. Okay, now we can get started. The first goal is to make, in both the second and third row, make your first digits of those 2 rows be 0. So if I take negative of row 1 and add that to row 2, I'll make it happen there. Then if I take negative 2 times row 1 and add that to row 3, I can make it happen there. So we'll do both of those row operations here. So row 1 is still left alone for the time being. All right, so let's see. Negative 1 plus 1 is 0. Negative 3 plus 5 is going to be 2. Negative 1 plus 5 is 4. And then negative 3 plus 1 is negative 2. All right, so there's your new row 2. What about, now let's deal with row 3. So negative 2 plus 2, well, that's also 0. So negative 2 times 3 is going to be negative 6 plus 6 is 0. Negative 2 times 1 is negative 2 plus 3 is positive 1. And then, of course, see, negative 2 times 3, rather, is going to be negative 6 plus 8, which is going to be positive 2. Well, it actually worked out. We already got row 3 in reduced row echelon form. Just row 3 is. We actually took care of another goal here of eliminating, we took care of goals 1 and 2 actually simultaneously. Because the next goal is to make the second digit in row 3 a 0. We just did it in one foul swoop, which was nice. So I'm going to say the next goal is to go ahead, make the third digit in both rows 2 and 1 also a 0. So if I literally just take negative of row 3 and add it to row 1, I can make it happen there. And then if I take negative 4 times row 3 and add it to row 2, I'll make it happen there. So let's go ahead and do that. For the time being, we're going to leave row 1 alone. Okay, let's deal with... no, we're not going to leave row 1 alone. What am I saying? I actually set up row operations. We're not leaving it alone. So 0 plus 1 is still 1. That hasn't changed. 0 plus 3 is still 3. Now, negative 1 plus 1 is 0. Alright. Negative 2 plus 3 is 1. So, there is part of the work done. Now let's deal with operations between rows 3 and 2. 0 plus 0 is still 0. 0 plus 2 is still 2. Alright, so negative 4 plus 4 is 0. Negative 4 times 2 is negative 8. Minus 2 is actually negative 10. And then you have your third row, which is still 0, 0, 1, and 2. Alright. Well, we definitely, both rows 2 and 3 have the required zeros in the required places, but the leading digit in row 2 is a 2, where it should be a 1. Let's start by taking half of row 2. If we do that, you'll get your leading digit to be a 1. So row 1 is left alone for a moment. 1, 3, and 0, and 1. Alright. So half of 0 is 0. Half of 2 is 1. Half of 0 is 0. Half of negative 10 is negative 5. And then, let's see, and that's, you still have your third row. Alright, so now rows 2 and 3 both have a leading 1 and the zeros in the places they should be. Our last goal, which will put us in reduced row echelon form, is to make the second digit of row 1 a 0. So if I take negative 3 times row 2 and add that to row 1, I'll end up making that happen. So let's see. 0 plus 1 is still 1. Negative 3 plus 3 is 0. And then 0 plus 0 is still 0. Alright, negative 3 times negative 5 is 15. Plus 1 is 16. And then you just have your other two rows that are already reduced. So now this matrix is in reduced row echelon form, which tells you directly that x equals 16, y equals negative 5, and then z equals 2. So the ordered triple that's going to be the solution to this system of equations would be 16, negative 5, 2. So there's the ordered triple. That's the solution of this system. Is positive 16, negative 5, and 2. 4 more problems. Alright, so there's your system of equations. 2x plus 10y equals 28. X plus 3y plus 4z equals 22. And then x plus 5y minus z equals 10. Let's go ahead and set up our matrix. So 3 equations, therefore gives you 3 rows. Coefficient on the x is 2. Then take that 10 from the y. Now notice you have no z. Since this is a 3 by 3 system, if there's no z, that means the coefficient on the z is 0 by default. So you'll put 0 in the z place, and then to the right of the augmented line, you'll have 28. Now, we have here, of course, second row, take the 1 on the x, the 3 on the y, the 4 on the z, and then put that 22 to the right of the augmented line. Third row, take the 1 from the x, the 5 from the y, the negative 1 on the z, and then the 10 to the right of the augmented line. And there is your matrix form for this system of equations. Now, we don't even need to swap rows, because notice the 2, 10, 0, and 28 all have common factors of 2. We can factor out a common 2 in row 1. So let's just start with taking half of row 1, which will make this a lot nicer to work with. So half of 2 is 1, half of 10 is 5, half of 0, well, that's still 0. Half of 28 turns into 14. All right. So now we got, let's see, still have row 2 and row 3. And I think you're all starting to see why we're not going to deal with anything greater than a 3 by 3 matrix in this course, because I'm already taking up a lot of space for 3 by 3s. Imagine how much more it would take for a 4 by 4 or even a 4 by 5. That's why you'd almost always want to use a graphing calculator for that, or some sort of calculator that can deal with matrices. But yeah, anyway, let's get back to what we were doing. So we want to make... We got a leading 1 in the first row. That's another reason I reduced. We have a leading 1 actually in the first row there now. We want to make the first digits in rows 2 and 3 a 0. So if I take the negative of row 1 and add it to row 2, I'll certainly make it happen in that row. And likewise, if I take the negative of row 1 and add it to row 3, I'll also make it happen in that row. So let's go ahead and do that here. So first row we're actually leaving alone to start with. First row isn't going to change yet. Now, negative 1 plus 1 is 0. Negative 5 plus 3 is negative 2. 0 plus 4 is 4. And then negative 14 plus 22 is 8. All right, so negative 1 plus 1 is 0. Negative 5 plus 5 is also 0. And then let's see, well, 0 plus negative 1 is still negative 1. And then, let's see, negative 14 plus 10 is negative 4. So we actually, once again, have done it. We actually got 2 zeros in row 3. Both, not only the first digit is, but the second digit of row 3 also is. Well, I think what we're going to do in this case, since we already have a negative in row 3, if we just take 4 times row 3 and add it to row 2, we can make the third digit of row 2 also a 0. So take 4 times row 3, add that to row 2, you'll make the third digit of row 2 also a 0. So let's see, row 1 is still left alone for the time being. Alright, so 0 plus 0 is still 0. 0 plus negative 2 is negative 2. 4 times negative 1 is negative 4 plus 4 is 0. 4 times negative 4 is going to be negative 16 plus 8 is negative 8. And then you have your row 3. Now, what I would suggest next, before we even try to make the second digit of row 1 a 0, you want to make the leading digits of rows 2 and 3 positive 1. So, because in the leading digit in row 2 is a negative 2, you're going to have to take negative 1/2 of row 2. And then since the leading digit in row 3 is negative 1, you're just going to negate row 3. If you do those, you'll be partway there. So, row 1, still leave it alone for a minute. Alright, negative 1/2 of row 2, so negative 1/2 of 0 is 0. Negative 1/2 of negative 2 is positive 1. Alright, let's see. Negative 1/2 of 0 is 0. Negative 1/2 of negative 8 is positive 4. And then just negate row 3, so you have 0, 0, negative negative 1 is positive 1, negative negative 4 is positive 4. Alright, we got rows 2 and 3 to where they need to be. Now we just need to make the second digit in row 1 a 0, then we're good to go. So if I take negative 5 times row 2 and add it to row 1, I'll make that happen. So let's go ahead and do that right quick. So let's see. 0 plus 1 is still 1. Negative 5 plus 5 is 0. 0 plus 0 is 0. Alright, negative 5 times 4 is negative 20, plus 14 is negative 6. And then you still have your other two rows. So now you have the matrix in reduced row echelon form, which tells you that your x value is negative 6, your y is 4, and then your z is also 4. So the ordered triple that would be the solution to this system is going to be negative 6, 4, and 4. So there is the ordered triple to this system, as negative 6, 4, and 4. Negative 6 plus 12 is 6 plus 16, 22. Yep. I like to sometimes check my work by putting in the values for each variable into one of the equations. If you get a true statement, you did it right. That's how you can check your work. Alright, I got 3 more. Alright, so we got x plus 4y minus 2z equals 3. We have x plus 3y plus 7z equals 1. Then we have 2x plus 9y plus z equals 8. Alright. So here's your new system right here. Let's go ahead and convert this into a matrix. So 3 equations means 3 rows. So row 1, you have the x term, which is 1, y is 4, z has a -2 coefficient, and then take that 3 to the right of the equal sign, put it to the right of your augmented line. Row 2, take the 1 on your x, take the 3 on your y, take the 7 on the z, and then put that 1 to the right of the augmented line. Row 3, take the 2 on the x, the 9 on the y, and then the 1 on the z, and then put that 8 to the right of the augmented line. Okay. So now there's the augmented matrix that represents this system of equations. Notice row 1, you have a leading 1 this time, so that's going to make life a lot easier. So my first goal, of course, get the first digits of rows 2 and 3 to become 0. So if I just take the negative of row 1 and add it to row 2, I'll make it happen there. Then if I take -2 times row 1 and add that to row 3, I'll make it happen there. So let's go ahead and do that. First, let's see. Row 1 is left alone for the time being. Alright, so let's see. -1 plus 1 is 0. -4 plus 3 is -1. -2 is actually +2. Plus 7 is 9. -3 plus 1 is -2. Alright, so there's your new row 2. Now, let's deal with -2 times row 1 plus row 3. So -2 plus 2 is 0. Let's see. -2 times 4 is -8. Plus 9 is +1. And then let's see. We have -2 times -2 is +4. Plus 1 is 5. Then we have -2 times 3 is going to be -6 plus 8 is +2. So now we've done part of our goal of making the first digits of rows 2 and 3 be 0. Now the next thing I'm going to say is that we make the second digit of row 3 become a 0. I can literally just add row 2 to row 3 and make that happen. So let's add rows 2 and 3 together and we'll get a new row 3. So row 1's still left alone for the time being. Row 2 is even left alone. 0, -1, 9, -2. Alright, 0 plus 0 is still 0. -1 plus 1 is 0. 9 plus 5 turns into 14. And then -2 plus 2 is 0. Alright, well, we have the zeros we need in row 3, but the leading digit's a 14. It should be a 1. So we'll need to take 1/14 of row 3. Let's go ahead and do that real quick. Get our next matrix. Still leaving row 1 alone. We're even leaving row 2 alone for the time being. Now, let's see, 1/14 of 0 is 0, 1/14 of 0 is 0, 1/14 of 14 is 1, and then 1/14 of 0 is 0. Now we've reduced row 3 exactly to how we need it. So, next goal I would have in mind is to make the third digit in rows 2 and 1 also 0. So I can do that by, if I take 2 times row 3 and add that to row 1, that'll make the third digit in row 1 become 0. Then if I take -9 times row 3 and add that to row 2, I'll make the third digit in row 2 also a 0. So let's do that here. So let's deal with rows 3 and 1 first. So 0 plus 1 is still 1. 0 plus 4 is still 4. All right, 2 times 1 is 2, minus 2 is 0. Then 0 plus 3 is still 3. All right, now let's deal with rows 3 and 2. 0 plus 0 is still 0. 0 plus negative 1 is still negative 1. Negative 9 plus 9 is 0. And then let's see, 0 plus negative 2 is going to be negative 2. Then you still have row 3. All right, next thing I'm going to suggest, before we negate row 2 and change that into reduced row echelon form, why don't we use that negative sign to our advantage? Just take 4 times row 2 and add it to row 1 so we can make the second digit in row 1 a 0. So yes, we're going to take 4 times row 2, add that to row 1 to make the second digit in row 1 a 0. So alright, 0 plus 1 is still 1, negative 4 plus 4 is 0, 0 plus 0 is 0. All right, 4 times negative 2 is negative 8 plus 3 is negative 5. And then you have rows 2 and 3. Okay. Well, the only thing left to do now, the leading digit in row 2 is a negative 1. It should be a positive 1. So let's just negate row 2, and we'll get to reduced row echelon form, which is going to look like your first row still 1, 0, 0, negative 5, negative 0, 0, negative negative 1 is positive 1, negative 0, 0, negative negative 2 is positive 2. Then you have 0, 0, 1, 0. Now we have the system in reduced row echelon form. We can get direct values of x, y, and z. So x is going to equal negative 5. Y is going to equal 2. And then z is going to equal 0. So the order triple that represents your solution is negative 5, 2, and 0. That would be the order triple. That's the solution to the system, is negative 5, 2, and 0. Two more problems, then we're done. Alright, so there's your next system. We have x minus y plus 3z equals 6. X minus 2y equals 5. 2x minus 2y plus 5z equals 9. Let me get a sip of coffee real quick. Maybe this will help my throat. Yeah, since I missed a lesson yesterday because of busyness, I'm doing a double lesson. I just taught a lesson before this, so I think that's why my throat's so dry. But anyway, let's go ahead and convert this into a matrix. 3 equations is 3 rows. So the first row, you take the 1 on the x, the negative 1 on the y, the 3 on the z. Then to the right of that augmentation line, you'll put the 6. Alright, second row, take the 1 on the x, the negative 2 on the y. Notice you don't have a z term there, so the default number that goes in the z place is 0. Then put that 5 to the right of the augmentation line. Third row, you have a 2 on the x, a negative 2 on the y, a 5 on the z, and then you have 9 to the right of the line of augmentation. So there's the matrix that represents this system of equations. I'm going to highly suggest that since we have a 0 in the z spot, that we move this to row 1 and move row 1 down to row 2. The reason I'm saying that is, yes, we can totally negate row 1, add it to row 2, and get rid of that 1, but then you're actually going to end up having to do extra work because then you'll have a z value filled in. You'll have to do the work in the end. Why don't we save ourselves some steps in the beginning, swap rows 1 and 2. So let's just swap rows 1 and 2 real quick. So let's see, row 2 becomes row 1, so that's going to be 1, negative 2, 0, 5. Row 1 became row 2, so 1, negative 1, 3, 6, and then row 3 we haven't touched yet. So 2, negative 2, 5, and 9. So now we got it to where we already have one of the zeros that we need. That's perfect. Now we can proceed with making the first digits of rows 2 and 3 become zeros. So if I take the negative of row 1 and add that to row 2, and then if I take negative 2 times row 1, add that to row 3, I'll make that happen in both rows. So yeah, let's go ahead and do that here. So row 1 we're just leaving alone for now, at least. Alright, so negative 1 plus 1 is 0. Negative negative 2 is actually positive 2 minus 1 is 1. 0 plus 3 is still 3. And then negative 5 plus 6 is positive 1. Alright, now let's deal between rows 1 and row 3. So negative 2 plus 2 is also 0. Negative 2 times negative 2 actually turns into positive 4. Minus 2 is 2. Then 0 plus 5 is still 5. And then we have negative 2 times 5 actually becomes negative 10, plus 9 is negative 1. So we got to where we want to be at first with the first two numbers of rows 2 and 3 becoming 0. The next thing I'm going to say we should do is make the second digit of row 3 also 0. I can do that by taking negative 2 times row 2 and adding that to row 3. So leave row 1 alone for now. Alright. We're even leaving row 2 alone for now. Alright, so 0 plus 0 is 0. Negative 2 plus 2 is 0. 3 times negative 2 actually turns into negative 6 plus 5 is negative 1. Negative 2 times 1 turns into negative 2 minus 1 is negative 3. Well, it's true that we haven't done everything we need to with row 3 yet, even though we got the 2 zeros we need. The leading coefficient's a negative 1. the leading term's a -1. But it is true that we need to make the third number of row 2 a 0. So why don't we use this negative sign to our advantage temporarily and just take 3 times row 3 and add that to row 2. So 3 times row 3 plus row 2 will give you this matrix. So, of course, 0 plus 0, well, wait, let me write in row 1. I haven't done everything I need to yet there. Alright. 0 plus 0 is still 0. 0 plus 1 is still 1. 3 times -1 is -3 plus 3 is 0. 3 times -3 turns into -9 plus 1 is -8. And then you have your final row, which will be 0, 0, -1, and -3. Alright. Now, next thing we need to do, we can actually do these things both at once, because we need to make that second digit in row 1 a 0. We have a leading 1 in row 1, so that's nice, and the far right digit's a 0. We just need to make the middle digit in row 1 a 0. So if I take 2 times row 2 and add that to row 1, I'll achieve that. And then the only thing with row 3 is the leading digit is a -1, which should be a +1. So we just simply need to negate row 3. So let's do those, and let's get our reduced row echelon form matrix. So 0 plus 1 is still 1. Now 2 minus 2 is 0. 0 plus 0 is still 0. Alright, -16 plus 5 is -11. And then, let's see, row 2 is fine. 0, 1, 0, -8. Now just negate row 3. 0, 0, -1 is +1. -3 is +3. So you'll end up with the solution of x is equal to -11, y equals -8, and then z equals 3. So the ordered triple that's the solution for this system is -11, -8, 3. That's the ordered triple that would be the solution. -11, -8, and 3. Alright, just one more problem and we're done for the day. All right. So here's the last system that we're doing for today. You have x plus 2z equals 4, x plus y plus z equals 6, 3x plus 3y plus 4z equals 28. So let's set up our matrix. 3 equations means 3 rows. So in the first row, the coefficient on x is 1. Notice we have no y term, so the default coefficient there would be a 0. But we have a coefficient of 2 on the z term. And then you'll put that 4 to the right of the augmented line. Second row, you have a 1 on the x, a 1 on the y, and actually a 1 on the z. And then you end up having 6 to the right of the augmentation line. Third row, you have a 3 on the X, a 3 on the Y, and then you have a 4 on the Z, and then you have 28 to the right of the line of augmentation. So there is the system that represents, there's a matrix that represents the system. Let me get a sip of coffee, Tina. Alright, pardon me. So, first thing I'm going to suggest still is make the first number of your second and third row become a 0. So if we just take negative of row 1 and add it to row 2, then if I take negative 3 times row 1 and add that to row 3, I'll be able to make that happen. Alright, so row 1 is being left alone for the time being. Alright, negative 1 plus 1 is 0. 0 plus 1 is still 1. Negative 2 plus 1 is negative 1. Negative 4 plus 6 is 2. Now let's deal between rows 1 and 3. Negative 3 plus 3 is 0. 0 plus 3 is still 3. Alright, so negative 3 times 2 is negative 6, plus 4 is negative 2. Negative 3 times 4 is negative 12, plus 28 would be 16. Well, this is good also because, let's see, we have a 0 where we need it to be in row 1, that's great. And we have a couple zeros where they need to be between rows 2 and 3. The next thing we want to do is make the second digit of row 2 a 0. So if I just take negative 3 times row 2 and add that to row 3, I'll make that happen. Alright, so row 1 stays the same, for now at least. Alright, row 2 will actually stay the same for the time being. Alright, negative, see, 0 plus 0 is still 0. Negative 3 plus 3 is 0. Negative 3 times negative 1 is positive 3. Plus negative 2 would turn into positive 1. Negative 3 times 2 is negative 6, plus 16 is 10. Well, we've certainly done it here, and we even got row 3 into the reduced form that we need because the leading digit's a 1. So the next thing we can do, we actually have this in what's called row echelon form, but we don't have it in reduced row echelon form. So in order to do that, what we're about to do here is make the third digit of rows 2 and 1 become 0. Then we should be there. So if I take negative 2 times row 3 and add that to row 1, I should make it happen in row 1. If I just simply add row 3 to row 2, I should make it happen in row 2. So let's see. Negative 2 times row 3 plus row 1, so 0 plus 1 is still 1. 0 plus 0 is still 0. Negative 2 plus 2 is 0. Negative 20 plus 4 is going to be negative 16. Alright, now let's deal between rows 3 and 2. 0 plus 0 is still 0. 0 plus 1 is still 1. 1 minus 1 is 0. Alright, 10 plus 2 is 12, and then you just have row 3, which is already reduced how it needs to be. And actually now this matrix is in reduced row echelon form, which gives us the value of x being negative 16, y would have a value of 12, and then z would have a value of 10. So therefore the order triple, that's the solution to this system, is negative 16, 12, and 10. And if you put those into any of the equations, they should check out. 12 is negative 4, plus 10 is 6. Yep, it certainly does. So that's it for this lesson. The next lesson we are going to start on determinants of matrices. The next lesson should actually be fairly easy. We're going to talk about the determinant of a square matrix, because you can only have determinants of square matrices, and we'll just deal with 2 by 2 matrices for the next lesson. So I hope everyone has a great day. Take care.